Day 270 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 153, find minimum and rotated sorted array. The difficulty level is medium, but don't worry because you already know we're going to keep the solution as simple and easy to understand as possible. But before we get started, y'all, don't forget to like, comment, and subscribe. And if you need any new Apple AirPods, go ahead and check out that link in this description. Now, let's see what the question says. Question says, suppose an array of length n sorted in ascending order is rotated between 1 and n times. For example, the array nums is an array of integers 0, 1, 2, 4, 5, 6, and 7 might become an array of integers 4, 5, 6, 7, 0, 1, and 2 if it was rotated 4 times, and an array of integers 0, 1, 2, 4, 5, 6, and 7 if it was rotated 7 times. Notice that rotating an array of a of 0, a of 1, a of 2, all the way up to a of n minus 1 one time results in the array being a of n minus 1, a of 0, a of 1, a of 2, all the way up to a of n minus 2. Given the sorted rotated array nums of unique elements, return the minimum element of this array. You must write an algorithm that runs in big O of log n time. So, now that we understand the question, or before we really understand the question, let's look at these examples to make sure that we fully understand what the question is asking, right? So in example 1, we have the input nums equals an array of integers 3, 4, 5, 1, and 2. The output is 1. Explanation says the original array was 1, 2, 3, 4, and 5, and it was rotated 3 times. So you might be wondering, why does it matter how many times the array was rotated if all we have to do is find the minimum element in the array, which is 1? The minimum element is going to stay the same whether it's rotated or not, right? So right here the minimum element is 1, and right here the minimum element is 1. The minimum and the output is 1. So either way the minimum element is going to be 1. But the fact that the array may be rotated is important when we're trying to write an algorithm that runs in big O of log n runtime, because when we're performing our binary search, the numbers will be in different positions, right? So as you can see, it starts in ascending order, right? So it's going to be rotated. So right here in this original array, it's in ascending order 1 through 5, right? But here it's not in ascending order. So when we're performing our binary search, we know that this left half will be in ascending order, and this right half will be in ascending order, but the whole array is not in ascending order. And when we're trying to write our algorithm in big O of log n time, that information is going to be important because we're going to need to know which half, where the ascending order starts, right? And where can we expect to find elements that are in this ascending order. In this case, 1 and 2 is in ascending order for the right half, and 3, 4, and 5 is in ascending order for the left half. But it's really just to help with our runtime. But let's go ahead and look at example 2, where it's a similar situation, right? We have the input nums equals an array of integers 4, 5, 6, 7, 0, 1, and 2. The output is 0 because 0 is still the minimum element. It says the original array was an array of integers 0, 1, 2, 4, 5, 6, 7, and it was rotated 4 times. So once again, as you can see, this left side is in ascending order, and this right side is also in ascending order. But just because it's in ascending order, just because these two are in ascending order, that doesn't mean that the 0 is always going to be at the beginning, right? Because if it's ascending order, we know that the smallest element is always going to be at index 0. But since it's rotated, now we know that the smallest element could be anywhere. So just another thing we need to keep in mind as we're writing our code. So let's look at example 3, the final example, before we get into the code, right? So in example 3, we have nums equals an array of integers 11, 13, 15, and 17. The output is 11. The original array was 11, 13, 15, and 17, and it was rotated 4 times. So as you can see, there's only 4 elements in here. So if we rotate it 4 times, that the array was going to be the same as it was as before because there's only 4 elements and it's being rotated 4 times, and the output is still 11 no matter how you rotate it, because 11 will always be the minimum element. So now that we understand the question, let's get into the fun part, the actual solution. We should get through the solution fairly easy. It's not that difficult, so let's get started. First thing we need to do is we need to initialize the minimum number to the first element of the array. So in order to do that, we could just come right here and we could declare a variable called min num equals nums square bracket 0. Because remember, in the original array, right, the minimum number will always be the first element because it's in sorted order. So we could just start like that. Even though we know it's going to change, we could just set it as that, just as a default value. Now we need to define the 2 pointers, one at the beginning and one at the right. So our left pointer will be at the beginning, so we're going to declare a variable called left, set that equal to 0, and then our right pointer will be at the end, and so we'll declare a variable called right, and we'll set that equal to nums.count. Excuse me, y'all. Nums.count -1. Boom. Now it's time to get into our binary search while the 2 pointers are not equal to each other. Or so we're going to say while left is less than or equal to right. That's going to start our binary search right there. First thing we need to do, we need to check if the subarray is already sorted, then we know the smallest element is at the left pointer. But we need to compare it with the current minimum and break out the loop, right? So right now, we know minimum is going to be set to the first element in the array, and we know that the smallest element array is going to be at the very left pointer, right? So we can see if they equal each other. If they don't equal each other, then we know it's been rotated and we need to break out of the loop. So in order to do that, we could say, if nums square bracket left is less, come outside those square brackets, and we say if nums square bracket left is less than nums square bracket right, boom. Then we're going to open up the parentheses and we are going to say min num equals the minimum, open up the parentheses, so equals min, open up the parentheses, min num comma nums square bracket left. Then we're going to come right here and we're going to say break. Boom, just like that. Now we need to calculate the middle index of the current subarray. So in order to do that, we could just say let mid equal left plus, open up the parentheses, right minus left. Come outside of those parentheses and we're going to divide that by 2, and that's going to give us our middle index. Now we need to update the minimum number with the middle element. So in order to do that, we're going to say min, we're going to change min num again, we're going to say min num equals the min, open up the parentheses, min num comma nums mid. So whichever is smaller, that's what we're going to return, and that's going to help set our pointers right, so our the group that we're searching in will get smaller and smaller. So that's going to help move our pointers so we could get closer and closer to the minimum index or the minimum element. Now, if the middle element is greater than or equal to the left element, it means the smallest element is in the right half of the subarray, or right half of the array. So because remember when it's sorted, when it's rotated, it'll be sorted like kind of in half. Like the right half will be sorted and the left half will be sorted. So once again, if the middle element is greater than or equal to the left element, that means the smallest element is in the right half of the array, right? Boom. So in order to handle that, what we're going to do, we are going to say, we're going to say if nums square bracket mid is greater than or equal to nums square bracket left, then we could open up the brackets and we could say left equals mid plus 1. Then otherwise that means the smallest element is in the left half of the array, so that means we can move our right pointer down some. We could decrement our right pointer. So we're going to say else right equals mid minus 1. And what that's going to do, this is going to move our right pointer to the left, or this is going to move our left pointer to the right, whichever one needs to be moved depending on this right here. So boom. Now all we need to do is return the minimum element that's been found. So in order to do that, we just come right here and we can say return min num, just like that. Now that should be all she wrote. Wasn't that much code, y'all. I told y'all it wasn't that much code. Let's run it, see, make sure it runs like it's supposed to. Ooh, it's accepted. So let's submit it, make sure it stays accepted. Let's see. See what that time looking like. Ooh, look at that, y'all. 0 milliseconds beats 100% of users with Swift, y'all. Those some good numbers right there. So I hope y'all learned something today, but before we leave, make sure y'all get one more look at the code. Make sure you understand what's going on. Read it, learn it, love it, internalize it. And yeah, I hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.